Good evening, all. Students, I request please inform your friends to join the session as today is the last date for this particular program. So, we are conducting the assessment in the last 1 hour. So, sir is going to take a class till 8:10. After 8:10, I'll be sharing a assessment link on a same chat. So, you can start taking it. So, before that, I request please inform your friends to join the session as soon as possible. Sir, good evening.
Yeah, good evening.
Yeah, you can start the session, sir.
Okay, sure. So, yeah, hello everyone. As as it is told by the concerned person from Excel, that it will be a last class for today. So, discussing of what all things we have done in the last class, I'll be straight away taking the charge of the same from there itself for today. So, as I'll be sharing my screen, I hope my screen is visible. Ishmita, can you please confirm it?
Yeah, yes, sir. Now it is visible.
Okay, thank you. So yeah, let me do the setup first. So I'll start it from here. So yeah, before doing the setup, I'll tell you the last run case that was happening for the quadcopter. So the mesh type was this, number of cells was this, velocity was this, CL was this, CD was this, and these are our numbers for the range and the endurance. Okay. So this gets fine for the quadcopter case. Now we'll be doing it for the uh, fixed wing case that we have done and completed it here. Just a minute, I'll be back. Just a minute. Hello, Sushmita, can you please confirm? Am I audible?
Yes, sir, you're audible.
Okay, okay, thank you. So yeah, we reached till here. So now we'll be taking the amount of mesh count that we are having. So let me do one thing. I'll just reduce the number of mesh elements first. So let me take it from 0.008 to 0.01, and this I'll do it as 0.3. Okay, now let me mesh it again. So because it is a large amount of elements, right? So 99 lakh 33,000, that is too much. So instead I'll come to a same ballpark number of around 3 4 lakhs. so that it will be easier for me to convert the solution faster. So that is the only case. So let me first see it here. Yeah, this is meshing. So from this, we'll get a proper idea about uh, and the conclusion that a wing-based modular solution is a better option when it is compared in comparison to a quadcopter-based solution. When you take care of the range and the endurance, which is very much needful in designing of your autopilot. So yeah, after this session for an hour, there will be a class also. There will be a test in which all the questions related to all the topics that we have covered will be there. So yeah. So now let me compare this here. So number says this much. So it is more or less the same. Now let me update it. So updating it. Once it is updated, let me go to, yeah, it is done. Now let me open it. So number of cores here is 5. Yeah. So the answer is opening, and we'll set up this problem and compare both the things at the same time. Oh, just a minute. I think something is running in background. That is hmm. Yes. Hmm. What is the problem? So yeah, let me open the Fluent like this. See if it is opening properly. Double precision, serial, bring it. Okay. So it is in. So let me do a serial command, I guess. There is some memory allocation problem that is happening in the parallel processors. So let us do a serial thing instead. Don't know what is happening. Yeah, now it is done. As this one got destroyed. Okay, so let me do one thing. Uh, I will export this mesh file. So what I'll do is I'll export this mesh file to a Fluent input file. Uh, I'll save it somewhere here. Uh, Fluent input file. Let me see if it works like that. So there is some cortex based error that is happening due to the memory allocation. So I think that is actually creating problem. So export page database, desktop. Enough memory is not there, it is saying. So don't see what is the problem, but there is some problem instead. Oh my goodness, there is some problem in the memory. So just a minute, just be with me. Let me delete some of the files. That is the reason why it is happening. I understood it now. So, okay. Mm, Let me delete whatever files is not required, and later on later on I can do it again. But now I need to show you first. So it's pointless to actually keep you waited for this. So yeah, I think some memory will be now free. So let me go to the design MTF recyclable. Okay. So now I think some memory will be there. Yeah, something is there. So I think we can remove some more things. So some more things like okay, yeah, yeah, recyclable. So you understood, right? What why it was not happening? It was basically not happening because the memory was not there, so it was not supporting uh, anything relatable. So we need to be cautious enough to basically first understand the problem statement. So all these kinds of challenges could also occur. So you need to be properly prepared, and these are something like you cannot actually avoid it. And sometimes it gets very difficult to track it as well. So yeah, now I think it would run. Parallel processors, no, double precision series. No, I think it should run perfectly. Yeah. So see, it's creating the things now. So that was the allocation of the memory that was creating problems. So once your memory is there, so that makes your problem statement very simple, and you can just now run your analysis. So I hope you understood the problem. There was some error in the memory allocation that was creating the problem. So now let me do it for you all. So, so this is mine. So we'll keep it minus 9.81, and this has equivalent Q omega SST. Now this has inlet velocity to be 20 meter per second. This has the wall velocity to be 20 meter per second again in the minus z direction. Okay. Now your wing reference area, you'll take it from here along the y for the aircraft 0.468. So 0.468 and it will be 0.5. It will be computing from the enclosure. Now your reference plane has drag to be CD, wherein CD from the aircraft in the Z direction and CL in the Y direction similarly. Okay, so now this is clear. Now I'll initialize the problem and run it. Okay, run it. So it is solving the Poisson's equation. It solved the Poisson's equation. It is running now. It is run. Now this is done. So let it run. So by the time it is running, we would basically try and understand that what are the other parts that we are going to discuss. So we'll be discussing the analysis of a propeller also to actually benchmark your data and understand that what is the current situation for your RPM based study and selection of the motor. So what we are going to do here is I'll tell you a flow chart based on which you will be able to understand it properly. So just a minute. So this is running, so it is creating some pockets of allocation. So this problem statement where this is a wing is put on analysis. Okay. So here, what we are actually planning is mm, will be this. Yeah. So what we'll be doing is so and just a minute. So let me save it first. Maybe haven't saved it properly, so that is why it is generating some problems. So Oh yeah, let me share my screen again. There is some problem with the system, which is why I'm not able to share it. Let me rejoin the session. Wait. So yeah, sorry for the delay. From my side, my network went suddenly. So uh, let me again bring up answers, and thereafter we can. So yeah, let me share my screen. Okay. So it's getting opened. So yeah, as we have done the first part of it, so the first part that we have done, I haven't saved it and I lost it, I guess. So no problem. I'll just make it again. Oh yeah, we have done two things, right? So in the first case, we have done it for the so first one we have done it for the quadcopter. Um, I remember the numbers actually. So uh, CL, CD, which are primarily important for us, I'll write them, and then CL power 3 by 2, power 3 by 2 upon CD, and then CL by CD. Okay, so here it was 0.1, this was 0.34, 0.34, and then this was CL power 3 by 2 upon CD, and this one was CL by CD. Okay, this is for the quadcopter. Similarly, we'll be doing it for the fixed wing that we have done it. So in the fixed wing case, we'll write the same thing and we'll capture it. Okay, so we'll do it again for you. So for that, let me bring it up. So Fluent, and then we'll save it first. We'll save it in this section, verbals. And that quadcopter is done, so we'll be only do focusing on the fixed wing part. So fixed wing, uh, opening its geometry in the space claim. That was a straightforward geometry, so we can set up the problem again. That is not a problem. It will happen fast only. Actually, it was complete uh, that thing from my side, so I lost the data. So that is why I have to redo it. But no, not a problem. Uh, Space claim is there. So now this is done. So let me first make the corrective statement. So now let me first keep it in this fashion. So first it will go, have to make the orientation correct. 270. Unity. 360. Okay, so now I think the orientation, yeah, the orientation becomes fine. So now I'll create an enclosure, repair the enclosure, and yeah, so it will be 300, will be 500, will be 1000, it will be 300, 300. Okay, so now this is done. Uh, this for physics. Now this is done. Now I'll go to the meshing part. Mesh, opening the mesh. Yeah. So earlier I have done it for the analysis of the ground vehicles. This will complete the analysis comparison of the aerial vehicle to show that the aerodynamic design is actually important when you are actually feeding in data in the autopilot for an autonomous vehicle, and that actually increases the range and endurance. That will be proved here. So yeah, this is done. So I'll name it now. This is outlet. These are the walls. This is the inlet, and this is the UAV. So I'll put a box select to it. This is the UAV. UAV. Okay. Now I'll put the naming as this is 0.3. This is 1.1 growth rate, 10%. This is 0.0. Let it happen. Once this is done, we'll be in a good position to. So yeah, one more thing was there in both the cases. The number of elements was 40 lakhs. So number elements. Here it was 4 lakh. Here it was 4 lakh. This is done. I'll update it. Once this updation is done, I'll save it and then try opening the setup again. Okay. So here double precision, parallel solvers, four solvers. Okay. I think now no problem will be created because we have saved it in another folder, which is having ample amount of space. So don't think there will be problem. 20 meter per second. This will be 20 meter per second. Huh. 0.48. The reference values, I'll put the answer as from the UV, it is 0.48, 438. Now this is 0.5. This is the chord length, the longest aerodynamic line along the path. Now this will be CD. CD will be reporting the plot, and CL will be also reporting the plot. Yeah, it's done. Now I'll initialize the problem solving the Poisson's equation in standard initialization, taking the arbitrary local values, not the global values. Now this is done. Now I'll do it for 100 time steps and run it. Okay. See, I think it should run now. So yeah, it has started to run. So now, so the problem was the storage problem also. So whenever you will be doing it at your end, whatever challenges you're facing, check the memory of the allocated solver first. And if the memory allocation is lesser, then first clear the memory, make the solution functionable and viable, and then run the solution. Okay. So yeah, it is running fast only. And we can see the CL and CD values also that are being plotted here. Okay. Let us see how much this is happening here. And then we will be able to. So the reason why this problem is occurring, no? So this is a global full level aircraft problem. So after doing this, we'll be doing an analysis which will be showing us for the wing locally also. So let me do it also. So instead, let me, instead of naming this, let me delete it and uh, oh, let me hide these things. Yeah. And let me name only the wing part. Mm, wing part. Okay, and this I'll be naming it as wing, and I'll be hiding this also, and then I'll be naming this entire body. So this is one body where I'll also name this body as UAV. And now I'll evaluate the lift of the wing alone. So this I'll keep it as 0.008, and other part I'll keep it as bigger one. Hmm. So this is 0.01. Okay, so now I'll mesh it again. By the time this is getting solved only. So yeah, it is solved only. So this is, I'll record the things 0.040 and 0.05. So see the drag value. Drag value is so less, right? So this only shows that the performance is so good. So the drag value instead of 0.34 it is 0.05. And lift we won't be recording for this because lift will be recording for the wing alone. So this I'll stop it, and I'll try to update this. Yeah, before that, let me close this. So drag for the entire aircraft is given to us now, similar to the one, because in the quadcopters that we analyzed yesterday, we were not having wings, right? So we were only having the so in the one that we analyzed yesterday, we were not actually having the wings. We were only having the canopy and the four propellers that were there. So in that case, we were not in a position to analyze it. Instead, uh, we analyzed the entire body completely, and then we evaluated the aerodynamic performance of that same. But here in this case, we have the whole aerodynamic body, and with the aerodynamic body, we also have the wings. So in to make an equal and comparative comparison, we are actually comparing the drag of the complete body and the lift of the complete body. But here, the lift of the body will be evaluated based on the wing, but there the whole body because there is no wing. So that is why. So that is done here. Yeah. So now I'll update it. Yeah, this is updated. Okay. So this is done. Now let me open this part. So double precision, parallel solvers, and number of solvers is 4. So this is running. So we'll be completing this and then we'll be able to conclude how the performance is different in both the cases. So this is minus 9.81. We'll be only comparing the. So see, the drag of the entire body was very less. When it is compared to quadcopter, it was around zero point 0.3, zero point 0.4. The drag of the entire body of a fixed wing was very less because the body is very sleek and there is no much chances of walls getting formed around it. Uh, so less chances of vortex shedding is there because it's aerodynamic profile. So always remember whenever you are designing an autopilot, keep into consideration to design for a certain kind of aircraft which is better aerodynamically. Okay, so now K omega SST. Okay. 20. 20. The 0.26. So here I'll be putting it as 0.2634, 0.5 from enclosure. Uh, Let me show you the drag also so that I have an idea ki the wings drag is how much. So with the wing, okay, lift, CL, wing, mm, let me solve it. So solving the Poisson's equation. Thereafter, running it for 100 iterations. Now this will probably let it run for some time. It is running and now the lift you can see is positive, right? So the lift is now positive because you're only analyzing the wing, right? You're not analyzing the you're not analyzing the tail or everything in common. So the entire so that shows that the overall lift of the body is negative. So you have to keep it at a higher angle of attack to actually make it functional. So in order to actually make it climb positively, you have to keep the entire aircraft at a higher angle of attack. Otherwise, it has to work more. So when you analyze the complete body lift, it was slightly negative or mostly zero. So in that sense, you have to keep the angle of attack higher to match the CL value. But yeah, it's all right. You can see here now the CL that is being generated for the body is more or less uh, there. CL is around 0.025, so it's all right, not a problem, but it's positive. So, so yeah, it's 0.25. So you can copy the formula here. See, so as you can compare here, the amount of endurance and amount of range, both are better in the case of fixed wing. So always fixed wing is better aerodynamically. That is has proved as well in terms of lift and drag because of fixed wing has a lesser amount of profile drag because the body is more sleeker, better aerodynamically designed, and the body is better in terms of aerodynamic generating capacity because it has a wing that is capable enough of lifting So a wing that is present here is also a functional element which is capable of generating a upward lift. So uh, but that is not in the case of a quadcopter, because a quadcopter is always functional on terms of propellers. Also, in terms of stability, if you say here, the stability is governed by the elevators in the case of a fixed wing. But in the case of a quadcopter, it is only a differential. So there are four propellers there. Uh, so if it want to roll right, it has to it has to systematically increase the thrust of this side and decrease the thrust of that side, this side. So this will make it roll right. If it has to bank, so front one it has to increase, this one it has to reduce, and these two remain constant. So then it will yaw right, and similarly yaw left. So and pitch means these two will at the front will be operating at a higher RPM, and this will be at a lower RPM. So it will pitch up, and if this will be higher, this will be lower. It will pitch down. Okay, so that is how uh, this thing will look like. So yeah, mostly this is done. So more or less it will lie in the same ballpark range. So now let me not waste time here. Instead, I'll show you how to select the torque in the case of a propulsion design system. So in the propulsion design, I'll just show you a layout diagram. So let me show it in the form of a sketch. So see, now supposedly you get a certain amount of torque value. That is, suppose 15 Newton meter. Okay. Okay, this is the torque. So you have to match this torque, and based on this torque ability, you will be selecting your motor, which will be used in the autonomous vehicle, be it a ground vehicle, be it a aerial vehicle. Mostly I am saying it for the aerial vehicle. So suppose you have a propeller which is of 30 inch. Okay, 30 inch. You'll be rotating this propeller at X RPM, and you'll be getting certain amount of thrust and certain amount of torque. Okay. Now, this X RPM will actually give you thrust and torque. But this thrust and torque will be slightly off in the first iteration. So you'll be iterating it in the loop of a parametric study, and then you will optimize this value of RPM to match this torque value, beat any thrust value, beat any thrust value. So supposedly you get a thrust value of around 700 Newton at a torque of 50. So suppose you get a 50 Newton meter of torque, but at that torque you get 700 Newton meter. So 700 Newton meter is the capacity of this propeller at that torque. That is okay. But now this 50 Newton meter that you got, from that 50 Newton meter, what you will be doing is you will be going to the data sheets of different uh, available companies. So like T Motors, like MGM Compro, like Robu, like Meslick. Okay, so these are the companies that you'll be fetching, and from that company's data sheet, you will be. So there are other methodologies also, like blade element theory method, but CFD methodology is basically one of the most trusted one if you're not doing a bench test data. And then from that thrust stand data or the bench test data or the CFD data, you get the certain amount of torque value, and that torque value you using that torque value and the RPM value. So that torque you will be knowing, that RPM you will be knowing, at which you have gotten this torque. So from there, you will get P is equal to 2 pi N T by 60. Okay. So this will give you the power. This will give you the power. And that power, where N is the RPM and T is the thrust. So this thrust will go here. And based on that, you'll be getting the power. So you are having now the torque and you will be having now the mechanical power. From this mechanical power, you get the motor efficiency of 80% and you get the electrical power. Okay. This electrical power, now you'll be using this electrical power and the torque to basically select your motor. That will be sufficing the values of this 700 Newton for this propeller, and also this 550 Newton meter of torque will be satisfied. At that rating, you'll be getting certain amount of power, electrical power, that will be sufficing for operating your entire powertrain unit. So be it one propeller, be it two propeller, be it three propeller, be it four propeller. You will be selecting one propeller based on that, and then you will be selecting your powertrain according to that regime. So that's your wholesome idea of selecting of the propeller also in the propulsion unit. So that brings us to the end of this coursework. And yeah, so I hope people who have joined in till now have understood a few things here and there about the propulsion, about the electrical power, about the mechanical power, about the torque, about the thrust in the propulsion unit. In the ground autonomous vehicle, you have also analyzed in ANSYS and also have studied different PPTs available that we have discussed in the class. In the aerial autonomous vehicle, also, you have compared the fixed wing UAV with the quadcopter UAV and then studied the flight mechanics regime of the entire coursework portion. So that brings us to the end of the class. Thank you, everyone. Now, the team will be sharing you a MCQ questionnaire which you have to fill. So, yeah, Shishmita, you can take over. That's the end of the course. Hello?
Yeah, sure, sir. Yeah, I'm there, sir.
Okay.
So we'll wait for 5 more minutes, sir. If students has any questions related
Yeah,
to
yeah, yeah.
topic, they can ask.
Yeah, yeah, definitely. So, students, if you have any questions for 5 minutes, you're free to ask anything and everything, whatever is there from the propulsion. So, this was one of the very much important things that we have discussed today, the propulsion unit, and this will be lying as a baseline for your selection of the motors, which will be used in the aerial autonomous vehicle as well as the ground autonomous vehicle. So, both the cases it will be used. So, please go through this carefully on how we have the certain amount of requirement for the thrust and we have certain amount of requirement of our body of torque, and from that we actually pre-calculate and get the value of the motor and select the motor. So this is the complete wholesome idea. You are free to ask questions for the next 5 minutes, and after that we can do the quiz work. So yeah, that is end from my side. I rest my mic and open for questions. Thank you.
Yeah, so dear students, I request please don't ask any LMS related or certificate related. If you have any query related to technical, related to topic, you can ask, sir. So we will wait for 5 more minutes. So if any question, you can ask in a chat. Okay, sir. If there is no question, I will continue.
Yeah, sure,
So,
sure.
yeah, thank you so much, sir. Thank you so much for your valuable class of all this 7 days. So, I hope this has been helpful for the students. Thank you so much once again. We will definitely connect with you again for next SDP or FDP, sir.
Definitely. Thank you so much. Thank you so much. Um, yeah. Bye bye. So, shall I drop or should I have to wait till the?
Uh, it's up to you, sir. No issues. You can, if you want, you can stay or else you can drop. No issues.
Okay, okay. I'll drop in sometime. Yeah, it's all right.
Yeah, yeah, sure, no problem. Thank you, sir.
Yeah.
Thank you so much. Yeah,
Thank you so much. Thank you so much, Yashmita. Yeah.
yeah. So yes, so dear students, as we inform, today is the last day, so we are conducting the assessment. So the assessment link I'll be sharing in a chat. So it is a MCQ question for 50 marks. So like 25 questions is from EV, that is electric vehicle, which we have completed 8 days. So, and the second 25 questions will be on autonomous vehicle. Okay. So, I request please read out the questions carefully and answer it. I'll be sharing the link right now, and we do have a timings. The timings till 8:45 you can take assessment. Okay, after 8:45 I will let you know. There are the important updates I have to inform you all. I will let you know. And one more thing, if you have done with the assessment, I request please don't drop the session. As you all know, you have to mark your attendance, and you wanted to know related to your the certificate and all. So after 8:45 only, I'll be sharing the attendance link. In between, I request not to ask for attendance link. So this assessment is also important. Please read out the questions carefully and start taking it. So yeah, that and sorry, assessment link is on a chat. You can start taking it. As I told, please don't drop the session once you're done with the assessment. Stay back in a session. I will give you the updates and all. Okay. Yes, so dear students, I hope you all completing the assessment. I request please don't drop the session. Kindly wait for 10 more minutes so that all the students will complete it. Then I will let you know about the certificate and everything. Okay. I request not to drop the session. Kindly stay online. We'll wait for 10 to 15 minutes. Then I will let you know all. Gautam, if you have raised your hand, I request to drop a message in a chat so that I can reply for you. So I hope you all doing with the assessment. I request if you have done with the assessment, kindly drop a text in a chat that you have done, so that I can assume you have completed the assessment. So five more minutes is there. So please drop a message as a done in chat. Yes, I'm getting so many responses that you all completed with the assessment. Thank you so much for responding, students. So I know you all legally waiting for attendance link. Before that, I used to share some important update. So related to the program and all. So then definitely I will share the attendance link. I request not to drop the session. So yeah. So right now I'll be sharing one GMB review link on a chat. So it means that you have to give the review. Like this review also is very important. So it is like whatever you have taught in a session, all this of 15 days, whatever you have taught, how the session was helpful, you can just mention in that GMB review, and you can give a review. And I request please don't mention it as a free. Okay, as you should not mention it as a free. You can just give one or two line like how the session was, how the trainer was, how you understood the topic. So I request please start giving it, as this is very important. Will definitely we will look to your review, and will work on the same. So yeah, I'll be sharing the GMB review link on a chat. So there are the two links. You can click on any link and you can start giving it the review. Okay. So soon after you complete this only, I will be sharing the attendance link. So I'll be waiting for 5 minutes. I request start giving the review. I hope you all understood. Click on the link and start giving the review. As I told, don't mention it as a free. Give one or two sentences like how the session was helpful for your education. I mean, the topic, everything. Soon after you are completed, you can just drop a message as completed so that I can assume you all done with the GMB review link. I mean, GMB review. Please don't ask the questions related to certificate. I will let you know in the end of the session. I request please be waited for 5 to 10 minutes. I'll definitely let you know. Okay, I hope you all gave the review, have completed. So yeah, please text it on a chat as you have done so that I can go for further. Okay, fine. Thank you for responding, students. There are many students, those who are responding. It's very thank you so much. So right now, students, we are starting one more program on on from this Monday. That is web coding using Gen AI. Gen AI tools. Okay. So I'm just sharing the registration link on a chat. If you are interested, you can join the session. It is also the same session as which we are conducting now. It is also for free, and it is also for 7 p.m. to 9 p.m. Monday to Friday. It is for 2 hours per day and 15 days. Total 30 hours of program, and definitely you will get the certificate if you are eligible. So yeah, I'll be sharing the registration link on the chat. Kindly, if you are interested, please start registering it. Yes, attendance link I'll be sharing at the end. Uh, I request kindly wait. As I told, I have shared the registration link on the chat. The program is Gen AI tools. It is also a FDP program, SDP program. The timings will be from 7 p.m. to 9 p.m. every day, like from Monday to Friday. If you are interested, I request you all to give like register, click on that link and start registering it. And also I'll be sharing the Zoom link. Okay, so I'll definitely, you will all get the Zoom link after you register. I mean, you will get the mail on Monday. So if still, I'm just sharing the Zoom link for Monday's SDP session on topic of Gen AI tools. You can use the link and join for the particular session. Join the session exactly at 7 p.m. Yes, the day one, uh, the particular day one Zoom link has been shared it on a chat. And okay, the questions I will answer. I'll definitely answer for all your questions. Okay, fine. So now I hope you all gave the GMB review link, and also you have registered to the link which I have shared. Fine. Right now I'm sharing the attendance link on a chat. Kindly mark your attendance without any fail. Okay. Yes, I know you all eagerly waiting for the attendance link. Fine. I'll be sharing it now. You can start marking your attendance. And related to certificate and all, I'll let you know definitely. Okay, attendance link has been shared it on a chat. So before you all ask the questions related to certificate, I would like to let you know all. So after the completion of a program, we require at least 10 to 15 days to issue the certificate. Okay. So I request you all please be waited for at least for 10 days. Okay. Within a 10 days, you will all receive the certificate for your register mail ID. Okay. And as you all know, we are already informed related to criteria of the attendance, criteria of the certificate. Like you have to secure 60% of attendance or above 60% of attendance, then only you will all get the certificate. If you have not marked your attendance, or if you have not secured 60% or above 60% of attendance, you will not get the certificate. Okay, if you are secured 60% of attendance only, you will get the certificate. As I informed, certificate we will issue within 10 days for your register mail ID. Okay, and related to materials and the recordings, all the materials and all the recordings will be uploaded to your LMS dashboard. You can go through that. Recordings you can access n number of time. There is no issues on that. You can watch the session recordings whenever you want. You can watch it. Okay. Yeah, so there is a questions which the students are asking. Qualification mark for the assessment. See, this assessment which we have conducted for your knowledge purpose. This assessment won't be effect for your certificate. For the certificate, we will only calculate the your attendance as we inform 60% of attendance is mandatory to get the certificate. If you have not secured 60% of attendance, for definitely you will not get the certificate. Okay. And there is one question from one a student. His name he have mentioned at Realme. Okay. So he was asking, I have attended multiple SDP programs, but I have not received the certificate. See, if you have not marked your attendance, if you have not secured 60% of attendance, you would have not got the certificate. If you have crossed the criteria, for definitely you will get the certificate. I request please check your attendance. I request you to drop a mail to edl@xlr.com, so our team will let you know how much days you have been attended and how much date you have marked your attendance. If you all mark the attendance for all the days, or if you secured 60 or above 60% of attendance, for surely you would have get it. Any other questions, students? We have some 5 more minutes. You can ask the questions. I'll just answer. Where can I see our attendance to confirm our total days of attendance? So no, sorry, there's no, like, you can't check your attendance. You should keep it in your mind that like how many days you have been attended. There is no any particular page or something you to check the attendance count. Yes, Harsh, can you please put the mail? Yeah, so I'll be sharing the mail ID on the chat, that which you can mail if any queries. That is edl@xlr.com. No, it is not possible in LMS. You can't check the attendance percentage in LMS. Okay, any other questions, students? I hope you understood related to the certificate. I request kindly wait for 10 to 15 days. You will get the certificate. Sorry, Sai Kumar Reddy. I am listening the class daily 15 days, but one day I am changed my name, and the changed name after I'm least 10 days. So can I get the certificate? Can I get the certificate or not? Sorry, I did not get your question, Sai Kumar. So if you have marked your attendance with the same mail ID, you will get it. It is not like you have changed the name, no issues, but you have to use the mail ID to mark your attendance. Like if each and every day you have to use the same mail ID to mark the attendance. I have not received the autonomous vehicle LMS mail, ma'am. So yeah, autonomous vehicle and electrical vehicle, we already gave LMS access for all the students, those who have registered. If you have not got it, please drop a mail. We will check and will definitely help you out. Ma'am, is this XLR program certificate we are attached in our resume. Yes, you can. It will help to you. No issues. You can attach. If we mark the attendance is okay, link you have given in a mail, in email, but did not put in attendance link while the class and feedback link. Whether so yeah, if you have not marked your attendance while I'm sharing in a live chat, you will not get the certificate. You have to attend the live classes and you have to mark your attendance. Okay, any other questions? How to know the attendance percentage? I already informed you can't see the attendance percentage. What happened if the leave the class and rejoin the class for several times due to the network issues? Will you consider the attendance for the day? It is depends on the attendance you have marked. If you have dropped the session and rejoined it, there is no issues on that, but the attendance you have to be marked. Ma'am, how we get the certificate? The certificate we will be sharing to your register mail ID. Tanishka, there is any a new group for any new course? No, no, there is no WhatsApp groups for any new courses. See, which if you are already there in a group, for definitely you will get the details of new batches. Yes, Gautam, if you don't have any questions to be asked, you can drop the session. Yeah, yeah. If students you don't have if you don't have to ask any questions, you can drop. Is it the mandatory to mark the present in your website every day? I had filled the link which was provided in lecture. Yeah. So no, in website if you have not marked it, there is no issues. The main thing you have to mark the attendance in the link. Okay, thank you all. I hope I answered all the questions. As I told, I request please be waited for 10 days for your certificate. 10 to 15 days. If you are eligible, you will get your register mail ID. Okay, thank you all. Thank you for joining of all this 15 days of program. If you are interested, I request please join for our new batches, which is starting from Monday. We'll definitely meet there. Fine. Thank you all. Good night, everyone. Study well. Uh, Good night.